In our last lesson, we looked at both arithmetic and geometric sequences. Pretty much the rest of this unit deals with series. And specifically today we will be looking at arithmetic series. So, quick review on what a series is. Series, you might remember from Algebra 2, is the sum of the terms of an arithmetic sequence, okay? The notation for an arithmetic series is that S sub n, and what that will indicate, that value of n, will indicate the number of terms that you are finding the sum of. In general, that S sub n, which is the sum of the first n terms, is called the nth partial sum. And basically what that means is that you are finding the sum of part of the sequence, okay, for a certain number of terms. We do have a formula for our arithmetic series to find the sum of a certain number of terms. Remember, this is just your general arithmetic sequence formula. And then our sum formula, S sub n, is equal to 1/2 n times a sub 1 plus a sub n. So basically, the number of terms here, the first term here, and then the last term here is basically what these are. So number of terms, a sub n we should know is the first term, and then a sub n is the last term of that series. Okay, so let's look at some examples. It says if air resistance is neglected, because obviously if we included that, this would be a completely different type of problem. So we're just neglecting that for the sake of what we're looking at. A falling object travels 16 feet during the first second, 48 feet during the next, 80 during the next, and so on. These distances form the arithmetic sequence 16, 48, 80, etc. So our first goal is to find a formula for the nth term in the sequence of distances. So this actually goes back to last lesson, just our general nth term formula for the sequence. So this is our a sub n equals a sub 1 plus n minus 1 times d. So again, going back to our last lesson, and because it's just the general formula, again, we're leaving a sub n in there. The first term, which is a sub n in our sequence, is the 16, and then plus, again, leaving n in there. And then we do need our common difference, so looking at what we're adding from 16 to 48, 48 to 80, that would be 32. And then distributing 32 to simplify this up a little bit. And then combining like terms finally gives us our nth term formula. From there, the second part is having us calculate the 5th and 10th terms of that sequence. So to do that, we are going to use that formula that we just wrote. So first looking for a sub 5, meaning I'm plugging 5 in for n. This gives me 144 for that 5th term. And then we can do the same thing finding term 10. So that would be 320 minus 16, which is 304. So So just a little bit of review with our arithmetic sequences. Now, really getting into our series here. It says calculate S sub 1, 2, and 3, which again, what these means sum. So what those really mean are the total distance an object falls in 1 second, 2 seconds, 3 seconds, etc. So for S sub 1, because it's just S sub 1, that's just the sum of the first one term, which is 16. Okay, we're going through this so you can really understand what we're looking at, not just kind of plug and chug into a formula. S sub 2 means I'm finding the sum of the first two terms, which from our sequence is 16 plus 48. So to evaluate that would be 64. And then finally, S sub 3 is the sum of the first three terms, which here is 16 plus 48 plus 80, which is 144. So that's all nice and easy with only 1, 2, and 3 terms. But if you look at the next example, find S sub 20. So, I mean, we could certainly go and do what we did in the last example where we're writing out the first 20 terms and adding them up. Instead of writing out all of those first 20 terms and then adding them up, that is the reason why we have the formula to find this sum. So using that formula, again, S sub n equals 1/2 n times a sub 1 plus a sub n. So we are looking for S sub 20. So our n term, or our value of n is 20. We can substitute that in. And then I know that my first term in this series is 16. But then what we need here is a sub n. Well, if n is 20, basically what that means is I need the 20th term. So kind of off to the side, what we're going to do is use the formula that we wrote up here to find that 20th term that we need. So plugging in 20 in order to find that term, which ends up being 624. So then I can take that value, substitute it back in my series formula that I need. And then it's just a matter of evaluating all of that. So this would be 10 times that sum. All of this should end up being 6,400. Okay? So that formula, a little bit less work than had we had to find all of those first 20 terms and add them up. All right, continuing on looking at our arithmetic series, you might remember from Algebra 2 what we call summation notation. So this Greek letter sigma is used in what we call that summation notation. This Greek letter indicates addition, which makes sense because a series is a sum. So just a quick review here to review the different parts of this summation notation. So what's in front of sigma is basically your general formula to find the terms. Down here is the first value of n. So a lot of times that's 1, but what we'll find in our class is that we might not start at 1 all the time. And then on top is the last value of n that you would use. So if we were asked to evaluate this sum, to find the different terms, what you could do is simply plug 1 into that formula. So 4 times 1 plus 4 times 2. And we would continue plugging in values of n into this formula until I reach 6, because again that number on top tells me where to stop. So then the terms of our series would be 4, 8, 12, 16, 20, 24. And then finally, to evaluate that, again, we would just add those up and get 84. So again, these are the terms. This is the actual sum. Okay? So the next example says to use sigma notation to write the sum of the first 20 positive odd numbers and then evaluate. Okay, so the first thing that we probably should figure out in this problem is what exactly would this sequence look like? A lot of times it's easy if you start off by looking at kind of the first few terms of the series. So the first 20 positive odd numbers. So the first positive odd number would be 1, then 3, then 5, then 7, and so on. Okay? So the first term is 1. Our common difference is 2. So it's kind of helpful to see this in order to identify the first term in that common difference, because we need to use that to write the formula that we need. So I'm going to plug in first term, which is 1. Again, I'm writing the general formula, so leaving n in there. Common difference is 2. So our general formula is 2n minus 1. So when we write our sigma notation, that was terrible, this formula is what goes out in front, okay? That is the formula that determines your values. We start by finding the first term with 1, and we're looking for the first 20, so that's what goes on top and bottom. So this is the first part of this problem, to use sigma notation to write it. Now we want to actually evaluate it. So to do that, we're going to use our series formula. So S sub n, 1/2 n, first plus, oops, the last, which I guess I can go ahead and write 20. So 1/2 times 20, the first term again was 1. The 20th term, again, we need to find. So in order to do that, we can use this formula, 2 times 20 minus 1, gives me that the 20th term is 39. That's what I need to use in my sum formula. And then just simplify. So all of this gives me 400. So evaluate the sum is what we did there. Next, we are asked to expand the sum and then evaluate. When you are asked to expand the sum, that means to write out the terms, okay? So to write out the terms, all we are doing is taking these values of n from 8 to 14, substituting them in, okay? So for the first one, -4 times 8 minus 4 plus -4 times 9 minus 4 plus -4 times 10 minus 4. I'm running out of room, but I'm going to continue down here. So -4 times 11 minus 4. And I'm continuing this until I get to this top number 14. I still need to actually then simplify to find the actual term. So this would be negative 36, negative 40, 44, and so on. So in a series, you may have noticed that instead of a comma in between, we write pluses, and that's just to indicate that we are finding the sum. And then to evaluate, it's just a matter of adding those up. So expand the sum is here, evaluate is here. All right. Last one simply says to find the sum. Now, n values from 1 to 30, I don't know about you, but I certainly do not want to write out 30 terms and add them up. Again, this is the reason why we have our sum formula. Even though this series is written in summation notation, we can still use this formula because from this, I can get the information that I need. So this tells me that I'm looking for the sum of the first 30 terms, which gives me that value of n. And then all I need is the first term and the last term. So to get the first term, I simply plug 1 in for I, which would be 15. To get the last term, which in this case is the 30th term, just plug in 30 for I, and that would be 160. And then just evaluate.